Okay, now what we did is we just finished the volume and structure topic, right, which was basically the last one in year 9, right? So obviously we're a little bit behind, but we can catch it back up again. Now what I'm going to do is we're going to start in the year 10 ones, right? And what I'm going to do is I'm going to do those ones that are easier to do at home, right? Kind of the ones that you can sort of look into yourself a little bit more, right? And this is normally the one that we do last in year 10, right? But it's quite a good one, right, for you to do, and you can get through it probably in about a week and a half. Okay, it's quite a small topic. Right, I've just put on the board there, right, sort of starter that I normally put in, right? And basically, right, what the topic is, it's a brand new topic, and it is all about atmosphere. Okay, now, and again, what I've done is I've chosen a chemistry topic, because I think I've definitely got your green books here, right, so you wouldn't be able to do biology, right, so it's in your chemistry topic, and what we might do is we might do another chemistry topic after this. This question is the one that we're going to answer at the end, that you're then going to go away, right, and then you're going to write a full question down, or a full written answer down. It's based on the flashcards, and what you would have if you were sat in the room now is you get flashcards. I might put them up online, right? But what it is you're going to be summarising this, okay? And the question is, describe Earth's early atmosphere. Now, I'm not talking about 7 o'clock in this morning, right? What I'm talking about is billions of years ago. And then the question is, what it was like 4 billion years ago, how has it changed over time, and how is it today? Right, because ultimately, 4 billion years ago, we wouldn't sort of chance of surviving. Right, would have lasted seconds if we were there. Okay, this then goes through all the different bits of information that you then require. I'm going to do the talky bit, right? And what I'm going to do then is I'm then going to kind of give you little things to do as we're going along, and then at the end, I'll give you the question to do. Okay, right, so the atmosphere today, right? And like we always do is if you then write down sort of individual little notes and things like that as we're going along about relevant information. For approximately 200 million years, the atmosphere has been like it is on planet Earth now, right? So 200 million years, right? Humans have been on planet Earth for a tiny little fraction of time. What we're then doing is we're destroying the atmosphere. Okay, and that's part of what we're going to be doing in the next few lessons. Now, currently, what the atmosphere is, right, on planet Earth is about 21% oxygen. And pretty much at sea level, wherever you go in the whole of the Earth, right, and you measure the amount of oxygen, it'll be about 21%. So in this room, in your room at home, wherever it may well be, in the Arctic, it'll be 21%. If you go up on top of Mount Everest, the percentage decreases because the atmosphere gets thinner. Nitrogen is 78%. Sometimes it's written down as 79%, so it varies a little bit. Right, but basically, 78, 79% of the air that I'm breathing in at this moment in time is nitrogen, right? It doesn't do anything, it has no benefit to me, it has no impact at all. It doesn't give me energy, it doesn't give me anything. It's just literally a gas that's there. Carbon dioxide is about 0.03%, all right? So in this room here, 0.03% carbon dioxide. If that level of carbon dioxide goes up, right, then that is then when it gets dangerous, and it doesn't need to be much higher, right, to actually start to cause problems. The other gases, right, which include water vapor and the noble gases, is often written down as 0.9%. Right, and what you'll see is the numbers, right, don't particularly add up to 100%. Right, what they are is they're kind of rounded. Right, but they are then the 3 main gases, and then argon is actually one of the main noble gases that's in the atmosphere now. Right, I'm probably breathing in 0.5% argon in this room, but because it's a noble gas, it doesn't do anything. So that pie chart there is what the gases are like on the atmosphere now. All right. Now, what I'm going to do is I'm going to kind of go through the history, right, of what actually happened right from the very start. First billion years, right? We've been, or planet Earth has existed for about 4.2 billion years, right? And some people think the Big Bang kind of makes sense to me, where you had all the mass of the universe in one place, massive explosion, right? And then what happens, all the planets and all the suns are then made from that. On planet Earth, for about the first billion years, right, what there was volcanoes. Okay, so just volcanoes like that, right, and that's basically where the planet itself, Earth itself, was cooling down. So all the volcanic lava was coming out, and then what it did, it then cooled down. It also released water vapor that condensed into the oceans. Now, hopefully, this little video will play, and you'll be able to watch it.
Trouble keeping track of your team's work? You need Asana. Try today for free.
Grammarly does more than catch errors. With Grammarly, you can find really good. Three-quarters of Earth is covered in water. It's why it's called a blue planet. But imagine Earth without its oceans. And instead, with all the water in the world gathered together in a ball. There's not that one.
It's quite amazing, really, in the fact that you've got planet Earth, and you think that 2/3 to 3/4 of planet Earth is water, right? But the water's only that deep compared to the actual size of Earth, right? And it makes a big blob about that big, right? The weird fact is they sometimes think that every single little drop of water that's ever existed, so I've got my brew, right, and my Mr. Grumpy mug here, right? Every single drop of water in my coffee there has been through a living thing 9 times. So Tyrannosaurus Rex drank that at some point, right? Weed it out, went into the oceans, then something else drank it, and then something else. 9 times they think that every drop of water has gone through something.
Really? Tons of water tossed into space. In Earth's formative years, it was hit by thousands of comets like this. So,
Right, so what that little video then was talking about was just talking about water, right? So what we did is, it all started off, right, first billion years as volcanoes. Water vapor also came out in volcanoes, and what it did, it condensed, formed rain, and then it went steam, and it just kept its process of just keep on cooling and cooling and cooling. I think it's quite amazing the fact that half of the water, right, came from outer space, from comets literally hitting Earth, right? Half of the water on planet Earth. Okay. Now, in your exercise books, right, what I want you to do is just write this little summary down of early atmosphere. Okay, so just write down the title, early atmosphere. And then it says here, when the planet was formed 4.5 billion years ago, there was no atmosphere. Right, so for example, Mercury, right, the closest planet to the sun, has got no atmosphere at all. Right, the sun's energy is so powerful it just blasts it off. There's nothing there, it's just a rock. During the first billion years, volcanoes released carbon dioxide, water, methane, and ammonia. Carbon dioxide would kill us. Methane would kill us. Ammonia would kill us. Water is the only one that's done a value into the atmosphere. There would have been little or no oxygen, right? But now we've got 21%. So I'm just going to give you literally a minute and a half, right, just to write that phrases down then about the early atmosphere, please. For the first billion years, right, all those volcanoes, carbon dioxide, pouring out. Water was pouring out. Methane was pouring out. And ammonia into the atmosphere. That was in the first billion years. All right, so that's a lot of years. Okay, now, then what we've got to do is we just then got to do a little bit of talking stuff about the evolution of the atmosphere, right? This is then basically what was then talked about before, theories about how the atmosphere was formed. First billion years, it was mainly carbon dioxide with little or no oxygen, right? Like Mars and Venus. There's probably also methane and ammonia. We just talked about that. Volcanoes also produce nitrogen, which gradually builds up in the atmosphere, and there may be small proportions of methane and ammonia. Okay? Now, this then, right, I'm going to give you a few minutes just to summarize something. Do you think planet Earth was almost all carbon dioxide? Where did that carbon dioxide go, and how did it disappear? Okay? Your task, I'm going to give you 3 minutes, is summarize this slide into no more than 15 words and include a balanced symbol equation for photosynthesis. So, algae and plants produce the oxygen that is now in the atmosphere by photosynthesis. So at some point, after 1 billion years, little algae appeared. Right? And what they did is they used the energy from the sun, photosynthesis, and they produced oxygen. Algae first produced oxygen about 2.7 billion years ago, so it's literally 2 billion years after Earth was created. And soon after this, oxygen appeared in the atmosphere. Over the next billion years, plants evolved and the percentage of oxygen gradually increased to a level that enabled animals to evolve. Right? So summarising that into about 15 words, what you need to do is you need to say, what is it, or when was it, that the algae appeared? What did they do to then increase the percentage of oxygen? And how long did it take? Give you about 2 or 3 minutes, 15 words, summarise that, please. Now, the actual numbers themselves, right, you don't need to remember the fact that 2.7 billion years ago, algae then appeared, right? You don't need to know that. You just need to go with the general sort of idea, right? So 4.5 billion years ago, there was nothing. There was a molten, basically a molten rock. After almost 2 billion years, right, this is then when waters then go into the atmosphere and the seas appeared, then algae then appeared. Now, one of the biggest questions, and I don't know the answer to this, is where did the algae come from, right? Was it, did it come from outer space, right? Just like half of the water on planet Earth, right? Did it just create? Did it God? Was it all those different things? I don't quite know, right? But basically, what happened is, after 2 billion years of planet Earth, algae then started to produce oxygen by photosynthesis. Then basically plants were on planet Earth for about 1 billion years on their own. There was nothing else, there was nothing eating them. Right? What the plants were doing is they were growing and developing, until eventually animals then were able to then evolve, right, and then started to appear. And then what they had then, they had the oxygen that the plants had created, they were able to breathe, and then it came down to us. Okay? Now, We should then just summarise that. And it also says in the little question here, a balanced symbol equation for photosynthesis. All right, and if you remember, when you were in class, I always say devil's number. All right, but think about what a plant does. So a plant is taking in the carbon dioxide. So from the early atmosphere, 90% or whatever it was, carbon dioxide, the algae had taken that carbon dioxide in. They've also used the water that came out of the volcano itself, right? Using light, they then made C6H12O6, which is glucose, plus 6O2. That equation you must know, all right? It'll almost definitely be on your exam. You must know the photosynthesis equation. And also, don't forget, if you flip it, respiration, which is what you're all doing now at home. Okay? So, photosynthesis then happened. Now, photosynthesis, right, didn't do all of it, right? So if you've got 90% of the atmosphere is carbon dioxide, photosynthesis is taking some of the carbon dioxide in, but also the carbon dioxide went to two other main places. It got locked in rocks. So for example, limestone, coal, methane, the carbon then became part of a compound, then got locked into the earth. All right, so limestone, if you go off to Yorkshire or all those different places, all the rocks there are made of limestone. What they do is they contain carbon and oxygen. All right, so a lot of carbon dioxide in the atmosphere was taken up by photosynthesis, but the two other massive ones are locked up in rocks, limestone, coal, and methane. And the second one, it dissolves in the oceans. So where you've got the sea, what happens is carbon dioxide dissolves very, very easily into seawater. All right. Now, what you can do then, if you're thinking about it, you can think about problems. Coal, right? So all that coal that is then locked underneath the ground, what are we as stupid humans doing now? We're burning it and releasing it all, right? Hence why we're causing a problem. We're getting the methane out of the ground, you know, things like fracking, right? Taking it out with crude oil, right? And what are we doing with that methane? What?
Sir, I haven't finished.
All right, okay, I'll just put it back for you.
I'm not finished with that other thing.
Well, no. Who's that?
No, the other one, sir.
Problem is, though, you have to
I'll
be
be
fast.
plants, whatever.
Right, okay. I'll give you another minute, right? But what you need to do
that
is you
one.
kind of need to listen in and try and write down as we're actually doing it. Right, I know it's difficult, and it's very difficult for me to actually judge timing, right? Because I can't see it.
It's slow as hell.
Okay, fair enough. Right, so it's not a case of copying this down, right? What we've got to do is just got to think about the steps, right? 15 words, algae, photosynthesis, right? 2.7 billion years ago, that's when they kind of appeared, right? And what they did is then, over the next billion years, they reduced the amount of carbon dioxide, but they didn't do all of it. Right, I'm going to have to move on now, Owen, because we need to get all the stuff done so I can get people. And what it'll do, the video will be there, and the PowerPoint's already uploaded. That is then your photosynthesis equation that we just talked about, and you should already have that written down somewhere. These, what? These are then the other two places in which carbon dioxide is locked up. Sedimentary rocks, like limestone, coal, and methane. Limestone, coal, and methane. And it's also dissolved in the oceans. Okay, so basically, it's going from 90% atmospheric carbon dioxide, reducing it down, right, so that then animals can then live down to 0.9% of the atmosphere or 0.03%, depending on numbers. 3 ways planet Earth did it. Number 1, photosynthesis. Number 2, into sedimentary rocks. Number 3, dissolved in the oceans. Great 3 6-mark question. How did the atmosphere reduce the amount of carbon dioxide, or how did the amount of carbon dioxide reduce in the atmosphere? Okay, right. So 3 ways in which carbon dioxide is then reduced in the atmosphere from the volcanic time. Number 1, photosynthesis. Number 2, locked up in sedimentary rocks, right? So things like limestone, coal, methane, locked up underneath the ground. Number 3, it dissolves in the oceans. So when I'm reading that carbon dioxide here, theoretically, some of that could then go and get dissolved in the oceans, even though there's only a certain amount that can actually get dissolved. This then, now we don't need to do anything about it, I just need to look at it, right? This then shows 4.5 billion years ago, which is down on this left-hand corner here, 4.5 billion years ago, all the way up to now. What it does, it kind of shows the process of all the different carbon dioxide and the carbon molecules that are involved. So it started off pretty much all carbon dioxide. For the first billion years, right, the carbon dioxide level went down, right, and that's because of the water. So the carbon dioxide dissolved in water. Methane got released, and that increased. It's only then, at this point here, right, that the carbon dioxide levels then started to actually prepare to decrease. Even then it goes flat along there. Right? What you can see here is this blue line is then the oxygen being made. That oxygen being made is then your algae. And so it's producing the oxygen. Carbon dioxide levels are still staying high because also methane is then disappearing. Because if you think if there's a load of methane in a room, what they'll do is just burn. All right? So as the methane comes down, carbon dioxide stays the same. Then at this point here, right, the algae then is using up all the carbon dioxide then plummets, oxygen gets to about 21%, carbon dioxide then goes down to pretty much 0. If this graph came up as a good GCSE graph, what you could do is then you would then have to explain. You'd have to explain the process of the carbon dioxide disappearing out of the atmosphere. You would have to explain that at 4 billion years ago, methane was then released out of planet Earth. At this point, 2.7 billion years ago, right, algae then started to appear. Algae got rid of the methane. It also kept the carbon dioxide level. Level of oxygen then came up. Then, at a certain point, once most of the methane had then gone, oxygen continued to increase and the carbon dioxide levels then dropped. Okay, and what you'll see at the end here, even though that's probably not appropriate, that is then us wrecking everything and making the carbon dioxide levels increase. All right, so that's then just something just to be aware of. Now, the task I'm going to give you, right, because theoretically this lesson then should finish at about 20 past, 25 past, right? This is then the question that I want you to write down in your exercise books. Okay, so I'll give you 1 minute, 2 minutes, just depending on lag time, right? Just to write that question down in your exercise books, please. And it's describe Earth's early atmosphere. How did it change over time? And compare it to the atmosphere today. So there is describe Earth's early atmosphere. How did it change over time? And compare it to the Earth's atmosphere today. All right, so immediately I can see that's a 6-mark question, 2 marks, 2 marks, 2 marks. Right, and what you've got to be able to do is you've got to be able to interpret that. So I'll give you 2 minutes, write that question down, please. Then what I'll do is I'll show you what we've got to do.
Aye, sir, I can't see anything on the board. It's just Mr. Leak.
You just see me? That's lucky.
Yeah, I just see initials on board.
Right, can anybody else not see anything? Or is it just Owen's lag?
No,
It was on there,
it'll just
so
be
it's
me.
gone off now.
It'll just be me.
Okay, right.
The question was on the board then.
All right, mate, I'll just put it back on. Thank you, Katie.
Yeah, it's back on.
But the biggest trick to any of these big questions is answering the question, which I know I've said in class before, and it's really dumb, all right? But if you don't answer the question, you don't get the marks for it, right? So, describe Earth's early atmosphere. How did it change over time? Compare it to Earth's atmosphere today, right? Question or answer I've seen many, many times is they would say, Earth's atmosphere had this, 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 and this. It now has got this, and this. And what you do is you've answered that bit, you've answered that bit, and the maximum you can get is 4. What you did is you missed this bit out over, which was the 2 marks. So what you've got to do is you've got to look at a question, rip it apart, and work out how many questions are within a question. All right? Now, this is then, and I've written the question down on the right-hand side here again, all right? This is then the answers, and it's basically on one of those flashcards that I'd have been giving you out. Okay, so describe Earth's early atmosphere is this box here, right? So this box here is Earth's early atmosphere. I don't know why I did a loop around there. How did it change over time, right? So you can say that the percentages changed, but you need to add a little bit more to it than that. So how did it change over time is this box at the bottom here. This is then when you're talking about the algae and you're talking about the oxygen in the planet, on the planet Earth. Compare it to the atmosphere today is then this one over here. And what you'll see is the actual percentages change a little bit, right? So as long as you've got a bit of an idea that nitrogen is about 80%, oxygen is about 21%, right? They will then end up giving you numbers themselves. So basically your task now is, I'll stay online for maybe about 5 or 6 minutes, right? And what I want you to do then in your exercise book is following on from that question, literally spend 10 minutes writing in full sentences, as if it's a proper 6-mark question, the answer to that question. And if you've got any questions at all, right, then what you can do is you can unmute yourself, right, and ask them. And I'm going to stay online until the big hand gets to 2, which is in about 6-7 minutes. This then obviously needs to be handed in on Google Classroom by about 4 o'clock today. Okay, and I know that a couple of people have got reasons why they can't do it, right, but that's kind of when it needs to be handed in. I've got to say, the more detail you put in, the better mark you can get. It's not rocket science, right? If you just write down little brief things, well, it had carbon dioxide and methane, and Aldi changed it to more oxygen, you're going to get nothing, right? Detail, facts, more information, that's then what you need to do to get the best marks. And at the end of the day, that's what we're interested in. Okay, I'm just going on to Google Classroom, right? See if there's any messages, and I'll put it back on in a second. If people have any burning questions that they want to ask, right, you can also email, right? I know one of you emailed me about a graph from last week, right? Quite happy to answer questions like that.
Sir, people want your help.
Right, Alexis, right, what I'm going to do is, in about a minute's time, I'm going to stop the lesson, and then what will happen then is the PowerPoint is already up on Google Classroom, so you can have a look back at it, right, and also then the video of the lesson itself will then be put up onto Google Classroom, and then you can just fast forward it or do whatever you want through. Okay, so I'll stop the actual recording now. Right, and then what it does then, it then takes